So, kind of a follow-up to my previous video about how to make stuff better with hotspots on the go, is here's some further improvements to the whole system I was proposing before. One is to have local computers do the computation more, such as either other people's computers nearby or the local servers. And by that I mean that the whole Google Docs idea said where you update the Google Docs and everything far away is, well, what if you send the information and the part where the large chunk of the software is sent is a local computer more? This will increase speed a lot because it has to travel less distance. You can use a weaker signal and you can update faster, so it would save a lot of the computation and it would look like your computer has a full software on it when it doesn't. So it'll be a good middle ground. Then you could have that one updating with the sharing and stuff more frequently with other people, so you could add like a buffer zone. Another idea I have for this whole thing is how to make how to have more local computers and stuff do this, and servers and stuff to boost the whole network. Is you can use this computation to heat up houses and stuff like that, which I discussed before, and a couple people work on it. And it can be more energy efficient way of heating up houses because you're already using up the energy for something else. Also, bigger computers, for a variety of reasons, are oftentimes more energy efficient than smaller computers. And the way they're more energy efficient than small computers is because you don't have to use all these wires and stuff transmitting back and forth. And we have all these wires transmitting back and forth. Wires, the farther distance as a travel from core A to core B to C between wires, instead of having this one giant compute chip or core A, B, C being integrated into one chip, the less power you lose. Most of it's lost throughout the wires. Also, the more efficient architecture you can design because everything is put together, so there's not a loss in communication speed. There's a huge loss of communication speed when going through wires or wireless signals. So stuff you can design to be faster and more computationally efficient. In that way, which can lower power usage, you can lower power usage by using fancier algorithms that only work well on big data or bigger data sets, or that work better on running the same algorithm on 20 different files. Instead of one file can save a lot of power. And you have a lot more room for just basic optimization of said algorithm through this whole entire thing. Another way is you can train it. When I talked before about training it to give the signal off at certain times of days and stuff like that, a better way of training it would be one that looks at it, and we can use this data to figure out. You can look at time of day usage, so when you're not using certain apps or certain programs as much, for when they update certain things. You can use other times, so like, do you use them more on weekends or less on weekends? You could also even look at weather data, holidays, and stuff like that incorporated into these fancier algorithms. And bigger computers will work better with fancier algorithms to optimize more. So you have that advantage also with bigger computers nearby. And also the more computation is on bigger computers, so less you have to do on your own device, and then more of your device can actually just be battery or for power generation. Another one is you can use these algorithms for the user and not for the user. What I mean by that is you can have a data algorithm that's trained for a wide range of people over a wide range of data, and this can learn all these subtle things that are probably less likely to be true, subtle characteristics, by looking at more data, because the more data you have, the better you can train an algorithm. But it might not be very good for a particular user because they might deviate from the norm. So first you train it on big data, then you make it fit better for the person. But this also less likely to get false trends. So there's two ways. Maybe you notice on Saturday and Sunday that they used up more of a particular type of data. But they only had the phone 7 days. So then you think, oh, they can keep using more and more data. But then if you have or you could say, hey, it's every 7 it's every 6 or 7 days that they use up more data, not a continuous trend upwards. So by using the algorithm that's already 50 million people, you can decide between the two more accurately. Or decide if they're actually an outlier. Maybe you can figure out apps before they even used it, stuff like that. But maybe someone has a particular trend and it's the reverse of everyone else, and you can figure that out better with the user. Maybe you learn that weekends are important compared to weekdays, so you adjust it, but you don't know how they're important, you just know they're important from looking at the big data sets. You can also put in the different types of apps to really help out with this, because different types of apps are going to have different usages. Typing speed, so you can see when people are more or less busy and figure out patterns that way. How much graphic intensity you're using in a type of graphic, is video or not, to give you an idea how much you have to update certain things. Sound intensity, the same thing. Computation intensity, a similar idea with computation, and also memory intensity for all these different aspects. And the final one that I did not put down here, but I also think will be very, very useful, is to make it so that you look at not only all these things I've discussed, but also you give user feedback in all these different ways, and that these user feedback tests say, do you want, like you say, I want faster, like you have the option to say, I want faster speeds, or I want speeds like this, or I was annoyed there. Or you can give user feedback saying, I turn off this feature, turn on this feature, more or less easily, so they can learn more for other people what they would like. Well, thank you very much for listening. Please like and subscribe. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours in a year, which is really hard, but with your help, I think I can do it. Also, if any ideas for future videos, comments, or suggestions, please leave them in the comment section below. Thank you very much again. Goodbye.